Okay, to solve for x here, I'm going to start by multiplying both sides by 2. So here I get e to the x minus 7e to the negative x equals 6. Now I'm going to rewrite this e to the negative x as 1 divided by e to the x, because that's what you do if you have a negative exponent. Okay, to get this e to the x out of the denominator, I'm going to multiply both sides of this equation by e to the x. So if I have e to the x times e to the x, that's e to the x quantity squared. If I do e to the x times 1 divided by e to the x, those cancel. So this is going to be minus 7 equals 6 times e to the x. Okay, now I will get 0 on one side. So I have e to the x squared. Subtract 6 e to the x from both sides. So minus 6 e to the x minus 7 equals 0. So what I have here is called a quadratic in disguise. The way I'm going to proceed is I have e to the x being squared here and e to the x being multiplied here. So I'm going to let u equal e to the x. So with this assignment, instead of having e to the x squared, I have u squared. So I get u squared minus, instead of 6 times e to the x, I have 6 times u minus 7 equals 0. So u squared minus 6u minus 7 equals 0, that factors as u minus 7 times u plus 1. And this is going to be equal to 0 if u is 7 or negative 1. So note that we wanted to solve for x. We have values of u here. Now we're going to use the fact that u equals e to the x. So u equals 7. That means e to the x equals 7. U equals negative 1. That means e to the x equals negative 1. But I know that e to the x can never be negative, so that's extraneous. And now e to the x equals 7, that means x equals the natural log of 7. So that is the solution to that equation right there.